Funding for this program is provided by Annenberg Learner.
Hi, I'm Pardeep Sabeti, and this is Against All Odds, where we make statistics count. Inference is the name of the game when we want to make conclusions about a whole population based on our sample data. In our module about confidence intervals, we learned how to use Z procedures to calculate a confidence interval for a population mean. The Z procedure works in cases where we know the population's standard deviation, but that's hardly ever the case in real life. Now we'll learn a way around that limitation. For times when we don't know the population's standard deviation, but want to figure out a confidence interval and do significance tests, statisticians turn to T procedures. These T inference procedures were invented in 1908 by William S. Gossett. If you're picturing a stuffy university professor, think again. Gossett was actually a chemist at the Guinness Brewery in Ireland, striving to find the best ingredients to use in their beer. Making ale involves frequent sampling of everything from barley to yeast to the beer itself. Gossett wanted to save time and money by using small samples and their standard deviation as an estimate of the unknown population standard deviation. But using the standard deviation derived from only a few data values doesn't give a sufficiently good estimate of the entire population standard deviation, and so he couldn't proceed with a Z procedure. After much laborious work, Gossett figured out a way around the issue and finally created a new class of distribution called the T distributions. Let's pay a visit to Pretty Things Beer and Ale Project, a modern brewer where Gossett's century-old innovations can still help with quality control. Brewing days start early for this crew. A small operation with no brewery of their own, Pretty Things had its beginnings in one connoisseur couple's love of all things beer.
Pretty Things is a company that my wife Martha and I started in 2008. Basically at the time to employ me. I was in between brewing jobs and we had just moved back to the US after living in England for 3 years. We needed to get me employed.
That modest goal met, they've grown and prospered to the point where Pretty Things is producing the equivalent of 8,000 kegs of beer every year. Their brewing process is a cross between chemistry and cookery. First, Dan Paquette tweaks pH and mineral levels in the water to mimic what today's recipe calls for, a water profile from the northwest of Belgium.
The beer we are brewing today is Baby Tree, and that is one of our year-round beers, and it's based on the old monastic tradition of very strong dark beer that would be served in monasteries to visiting monks. Or abbots, more than likely. It was their best beer that they would make, so they would try to impress people with it. That was the whole idea. And this is our take on that.
The next big job falls to Martha Holly Paquette, who's responsible for milling the malted barley that's the base of today's beer.
A lot of the grain comes from a silo outside, and that's what we call the base malt, and it's just sort of a very sort of gentle flavor, pale color, and then we add flavors by using different types of grain.
Milling cuts each grain in half so the starch and enzymes within these toasted seeds are accessible.
And then it's going to come down this chute. Then we're hitting it with water. It's going to hydrate the grain, which allows the enzymes to break the starch down into sugar.
This hot porgy mix is called the mash, and it cooks for about an hour, with Dan monitoring the temperature closely.
So I'm just raising the temperature of the mash to get a different blend of enzymes. I was at 152, and I'm going for 158.
Then it's pumped next door into the lauter tun, where the spent grains are separated from the clear liquid. At this point, the proto-beer liquid is called wort. Next, it heads to the kettle, where the hops get added.
So inside the kettle, you're boiling for an hour You're sanitizing the liquid, you're creating the bitterness, you're separating out the protein. Then after the boil, you're shipping to a whirlpool, which is essentially like a bit of a centrifuge, where you're allowing all of that material, hops and protein, to come out of solution and form a cone so that we can draw the sweet wort off of that.
Dan cools the wort and sends it to the fermenting tanks, where over the course of several weeks, the yeast will work their magic and transform the sugars in the wort into alcohol in the finished beer. But before the yeast can get down to it, Dan takes a wort sample to check the liquid's density.
Shall I be hopeful or pessimistic? Because I can go two different ranges.
Dan and Martha aim for a density reading of at least 19.5 degrees Plato for this pre-fermentation wort. Every degree Plato means the liquid is a certain amount denser than water.
I'd call that 20.3. That's ridiculous.
20.3 is good.
It's really good. I mean, I wouldn't mind making the beer like that.
The density tells Dan how much sugar is in the wort. It's kind of like measuring the potential for fermentation in this batch, and it looks like they won't have any trouble hitting the 9% alcohol content listed on the Baby Tree label. There are several points in the brewing process where Dan and Martha take samples to make sure everything's running smoothly.
This is our last chance to dump the beers if they've turned out rubbish.
So far, they've never had to dump a batch, thanks to their careful craftsmanship and some judicious sampling. Let's imagine that Pretty Things wants to see how closely their production of Baby Tree beer is hitting their pre-fermentation density goal. We can go back in their records to collect data from a sample of 10 batches. Since our sample size is small, its standard deviation could be quite far from the actual population standard deviation of all the Baby Tree beer they've ever brewed. So the Z procedure won't work. It's time to call on the T procedure that brewer William Gossett invented. Compare a T distribution to the standard normal curve. You can immediately see they share certain features. They're both roughly bell-shaped and symmetrical with a mean at 0. But the T curve is broader with a shorter peak and its tails are higher. These fatter tails mean that there's more probability of getting results far from 0. That's because the sample standard deviation varies from sample to sample, particularly when the sample size is small, adding uncertainty. Another difference is that although there is a single standard normal distribution, there's a different T distribution for every sample size. As our sample size increases, the sample standard deviation S gets closer and closer to the population standard deviation sigma. The curve narrows and gets closer to the standard normal curve. Remember, the different T distributions are specified by sample size. Of course, statisticians have their own particular way of saying that. Instead of saying sample size, they use degrees of freedom. The degrees of freedom for this T statistic are always 1 less than the sample size. In our beer example, the sample size is 10, so our degrees of freedom are 9. Here are 10 density measurements Pretty Things got with their hydrometer. For these calculations to work, our data must be from a normal distribution, which is a safe assumption in this case. Now we can calculate our confidence interval for the population mean for the density of all Baby Tree beer. Here's our equation. X bar is the mean of our 10 density samples. S is the standard deviation of our sample. Our sample mean is 19.72, and our calculation for S gives us 0.85. N, of course, is 10. We choose whatever confidence level we like. Let's go with 95%. We can look up in a t-table or use software to find the appropriate t-distribution critical value. We chose 95% and need to look for 9 degrees of freedom. That gives us 2.262 for t-star, the critical value for our 95% confidence interval. Once we've plugged all the values into the equation, we calculate the confidence interval for the mean density of Baby Tree beer to be 19.72 plus or minus 0.61. Like all confidence intervals, we're looking at a point estimate plus or minus the margin of error. The interval estimate 19.11 to 20.33 degrees Plato gives us a range of plausible values for mu. You might remember that the z-star, the critical value for a 95% z confidence interval, was 1.96. Here, the t critical value of 2.262 gives us a wider confidence interval. That's the price we pay for having a small sample and not knowing sigma. Pretty Thing's goal for their Baby Tree beer is a density of 19.5 degrees Plato, which tells them they've got the right amount of fermentable sugars in the wort. Using the confidence interval we've calculated, we can say with 95% confidence that a 19.5 population mean is safely within our range. So based on our sample, it looks like Dan and Martha are consistently hitting the mark. The personalized care and attention the Pretty Things brewers put into every batch is certainly paying off with its growing legion of fans.
So we're at Bukowski's, which is a bar in Cambridge in Inman Square, and we're doing a pint night.
So basically, pint night is when people come in, they buy your beer, you give them a free pint glass. It's if we were a young company, it would be a desperate measure to get people to drink our beer, but we're just trying to give nice, cool things to our customers, basically.
Drink beer.
Yeah.
Pretty Things enthusiasts turned out to share in the beer love. Even one pregnant fan due to give birth that day.
I'm 9 months pregnant, so I can't have any, but I love Baby Tree. It's one of my favorites.
You gotta take one for the team. We're drinking for 3 here.
Cheers.
It's great beer. Great beer. Yeah, thank you for the glass. We're adding to the collection.
See, statistics really does have some very practical applications. For Against All Odds, I'm Party Sabetti. Cheers.
Funding for this program is provided by Annenberg Lerner. For information about this and other Annenberg Lerner programs, call 1-800-LEARNER and visit us at www.lerner.org.